My name's Keller. I'm the CEO and co-founder of Neurosity. I lead the hardware as well, the hardware design. I've been put in this position for many, many reasons, but one of them that I always like to go back to is that I've had my own plethora of different, mental health issues, from depression, anxiety, and ADHD that have really pushed me to understand that the first killer application of brain-computer interfaces is probably one that helps people overcome the human condition they were born with. And today I want to sort of talk about how we're creating a new generation of software that assumes nothing about the user and only gets better over time by predicting what will help the user in this self-learning, self-supervised manner that creates incredibly efficacious software that feels personalized to the user and builds this personal relationship towards this future of symbiotic computing where computers are learning from humans at the same rate that humans learn from humans. And that's what we'll sort of dive in. So in summary, we've been able to create a system that essentially you put our headset on. It's this 8-channel brain-computer interface. It just goes on the back of your head. And images the entire brain. That's as fast as it takes to put on. It's using dry sensors. It has a whole quad-core computer on it. And it's really this like general purpose developer kit that we've been able to create that allows us to rapidly test what software people find valuable. And the most valuable one we found is that no, focus tracking doesn't help because focused people know they're focused and unfocused people are very aware that they're not focused. So it doesn't really work like a running, knowing your pace while running doesn't really extrapolate over to knowing how focused you are. But what we did find is very useful is that we can use sounds and predict exactly what sounds or audio embedded within music will actually cause a change in brain activity in the wearer's mind. And that's really what we've been able to pioneer is the system that within 2 minutes people start to actually feel a perceived change in focus. And so that's really what we've been able to start pushing. And on the inside of this device is a quad-core computer. There's a state-of-the-art brain imaging chipset that allows you to actually image the brain 256 times per second. This is all being compressed and computed locally on the device. No raw data is being sent to a third party or to a remote server in order for the user to get value out of it. It all happens instantaneously on top of their head. And this is something called EEG. You can see here, this was just something I recorded the other day, where you can clearly see the difference between, when I open my eyes or I close my eyes, you can see this rapid change in brain activity called alpha signal that is very indicative of this type of brain activity. And so what we've been able to do is, create a cloud-first architecture that actually allows you to, from any number of clients, subscribe to the data that's coming off of this headset. So at the same time that the user is using an application, we can have a remote server that is also subscribed to that data that's then training a large model or leading to a data set that trains a large model. You can have a remote clinician be able to remote in and see the brain activity and modify protocols for neurofeedback in real time. Anything is possible because, up to 1,000 different devices can connect to a single headset. And we all have, authentication and authorization that allows you to actually securely get that brain activity and leverage that. And what this allows you to do is immediately upload a data set to the internet and be able to then look at that. So on the right is what you'll see a user will actually see when they do a shift into focus session. So they want to get focused. They put the headset on and they hit focus. They put their ear pods in and the software is continuously trying to figure out how to modulate the music in order to get the largest increase in gamma activity. And on the right is what the user will see. It's in the app. It's something fun. It's easy to understand. But on the right, you can dive in deeper into this data set. You can then take this data set and use that to train a foundational model. And that's really where a lot of our work has been going. As we've been able to amass across over 500 people, over 5,000 sessions, 300 million data points that are now being used to train a EEG foundational model that will then be used for fine-tuning downstream. But this is all enabled because of this cloud-first architecture, where we've created a system that's actually useful for people to use. They're then able to use it consistently, and we're able to get that longitudinal data and build an encoder, decoder that's actually able to predict the next brain state because of all of this data we've been able to collect. But you're not able to collect any data if you don't create a useful application for people. And then, another part of this that we've been really working on is imagined thought recognition. So similar to how the Neuralink poster or Neuralink, first user just came out, who's able to control a mouse just by thinking. It's not actually when they try to move their arm, it's when they imagine the movement that they're successful. And a lot of this information you can also pick up on from an EEG headset like ours. And so with the power of, edge computing, you're able to actually, run up to 5, 6 different classifiers in real time, all from the headset that are predicting different imagined thoughts. On the screen here, you can see left arm. So are they imagining moving their left arm? Are they imagining moving their right arm? Are they imagining moving their tongue? Are they imagining biting a lemon or doing mental math in their head? And all of these have been exploited by developers all around the world who have done everything from turn a coffee machine on to connect with GPT-4 to summoning a Tesla. All of these different things can be tied to different actions and are pretty amazing. But this is really using classic machine learning. And what we hope to do is take the EEG transformer that we've been developing, that foundational model, and improve all of the downstream applications to that. So that's really the benefit of collecting data, is then you're able to create a new subset of data to then perform actions on. And so that's really where this foundational model that we've been working on comes into play. And that's really thanks to a number of people around the world who are trying to create these foundational models, but they all sort of have the same issue, which is they need to be trained on billions of data points. But getting billions of data points from EEG and from brainwave activity is incredibly hard. So what we've been doing and what the community's been doing and what every single neuro startup has to do is go comb the internet for as much EEG data as possible, train a first model that's learning the intricacies of this data, but then we have to then fine tune it on our own data, to be able to actually get use out of it. So that's really where this NeuroGPT concept is coming from, and really what the next generation, of applications will be built on. So we'll do a hackathon here in a few months where everyone at the hackathon will be tasked with building an application using the embeddings from this foundational model to create, something that can tell if you're having a panic attack, wanting a cigarette, many different types of little applications like that to start really fostering and create a spark of innovation that the field really needs. And that's really all sort of leading to this big concept, which is, hey, how can we reduce the form factor of this device to make it more and more accessible? And so that's really where, I'm one of the first people to really start calling it, but a pocket-sized EEG device. What we learned is that, most of the mental health issues that I talked about first are located in the frontal lobe of the head. You don't need to be measuring the back of the head for the visual cortex. You don't need to be measuring the center of the head for the motor cortex to do those like imagined movements. Everything just depends on the front of the head. So you can take this little thing, stick it to your head, and then run your actual experiments, and run that whole user application, that shift into focus, that modulating that mental health, brain activity, just using a tiny little pocket-sized device. So that's what we'll be rolling out over the next year or so, is this new generation that you can take anywhere with you, supports all head shapes. We learned going into different markets that different cultures have incredibly different head shapes, so creating a device that fits all of them is incredibly challenging. But when we create a device that's this small, we actually have a shot at being able to fit on all heads. So that's where you continue to see it. We're taking the same foundational model that we've trained with this larger headset, and we're then able to map that to this smaller headset and be able to get, improve the efficacy of this smaller form factor, leveraging all of that data that we've been collecting over the past few years from our larger headset. So, we really live at this great time where you can compress data and map it using these transformers to really create something that's much more powerful than it would be just on its own, measuring with no, pre-informed information. So that's really where we're going, and that's it. Thank you.